Hello everyone. If we analyze this year's RMO 2023 paper, we'll see that there are 6 questions. Some of you must have appeared after qualifying IOQM. Those who are going to appear next year, this video mainly for them. And I'll be discussing up to what step if you have completed. Up to what step if you have completed, you can expect some marks over there. These descriptive questions, if you have started properly with the proper concept, you'll get some marks even you are not able to complete the sum. Even in the sense of that half of the sum or 1/4 of the sum done, you'll be awarded some marks. But your approach should be correct. This session, I'll be discussing the integers questions they have asked. I'll not say number theory, questions from number theory. Number theory is something which is big, but integer which was there in your class 9-10 syllabus just 2-3 years before, now it is removed, will help you to understand and then to solve the sum. So let us go through the question paper, sum number 1 and sum number 3. These two questions are asked from integers. Okay. See the question given here in problem number 1. If we go through first, it is given n be the set of all positive integers and s is equal to, s means the set. This set is equal to a, b, c, d, where a, b, c, d belongs to n to the power 4. N to the power 4 means it is actually Cartesian product of natural numbers. Those who are in class 8, 9 or 10 level, they haven't done Cartesian product. But remember, whenever this kind of symbol is given, these numbers A, B, C, D being taken from the set of natural numbers. Maybe 3 numbers, then you will write n cube. Maybe 2 numbers, we will write n square. Now, you have to see the condition given here. ABCD chosen from set of natural number and the condition given. A to the power 4 plus B to the power 4 plus C to the power 4 equal to D to the power 4. Now, the problem is to find the largest positive integer m such that m divides ABCD for all ABCD belongs to S. For all, note this statement. M will divide for all ABCD belongs to S. How will you approach this kind of sum? Will you apply algebraic formula or polynomial concept, all these things here? No. Very simple concept. N is given as the set of all positive natural numbers. So we'll try to get the trivial solution. I mean the least values of A, B, C, D for which this equation is valid. If we can get the trivial solution, then you can approach other solutions. But you will say that infinitely many numbers can satisfy this condition. I agree with you. But see the problem here, it is given, find the largest positive integer m such that m divides ABCD for all ABCD belongs to S. It will divide the least one, it will divide the biggest one, it will divide in between all the integers in the form A into B into C into D. Okay. The question is, it will divide the product. So suppose if the smallest value of the product is, suppose by any calculation you are getting 21 and the largest value is 2121. Your problem is to find the integer m which will divide A, B, C, D. I mean that 21 as well as the other values. So those other values may be many in between those two, 21 and 2121. But largest positive integer which will divide 21 first and then other numbers and then up to 2121. So you have to find actually the minimum possible value of A into B into C into D. Okay, it is given that this statement you have to notice. M will divide A into B into C into D for all ABCD belongs to S. Need not find all integers over there, just find the smallest one in the set. Then the problem is solved. So let us try with the simplest value of A, B, C, D. Little bit idea of integers will tell us to get the minimum most value of A, B, C, D. If we take integers in this form, say 1, 2, 2. Then 1 square, 2 square, 2 square is 9, which is 3 square. You can say that if it is multiple of 1, then also it is satisfied. I agree with you. But I found the trivial solution here for which this equation is valid. Because 1 square, 2 square, 2 square equal to 9. This is 3 square. If we take 2 square, 4 square, 6 square, no, 2 square, 4 square, 4 square, then it will be what? This is 6 squares. Okay. We can make other observations also. Like if we have taken A, B, C, I am writing the values of A, B, C this manner, that 1, 2, 2, it is satisfied. If we take A, B, C as say 2, 3 and 6, then also it is satisfied because this will give us 3 square and sum of the squares of these integers will give you 7 square. If we take A, B, C as 3, 4 and 12, then what do you get? Because these are just common calculation we apply in any arithmetic calculation also. 3 square plus 4 square, you all know 5 square, plus 12 square will give you 13 square. If you take A, B, C as say 4, 5 and then 20, then this will become 20 square plus 25, that is 24, 4, 1, that is 21 square. Do you find any pattern over there? Are they following any pattern? Yes, they are following a pattern. Here, if we take integers A, B, C in this form, n plus 1 and say n into n plus 1, then we are getting all the values here. For n equal to 1, C, 1, 2, 2. For n equal to 2, 2, 3, 6. For n equal to 3, 3, 4, 12. 4, it is 4, 5, 20. Okay. Now, after getting the values of A, B, C in this form, what will be the value of D? Does it give any special sequence, special form like ABC there? Let us check. If we make square, if we find A square plus B square plus C square, then what do you get? You will get it in this form: n square plus n square 2n plus 1, n square 2n plus 1. This is going to be n4 plus 2n cube plus 3n square plus 2n plus 1. One can write this one as n square plus n plus 1 whole square, or n into n plus 1 whole square. So it's very interesting to note that our D is just the integer after n into n plus 1. See, 6 plus 1, 7, 12 plus 1, 13, 20 plus 1, 21. So sum of these three is equal to this. So if we write ABCD in this form, where we replace n by what? We replace n a by n, b by n plus 1, c by n into n plus 1, and d is the next integer. Integer after c, it will be n plus 1 plus 1 over there. So right, integers are of this form, and the least value we have seen there, it is 1 2 2 3. So if we go for finding the product, that a into b into c into d, the least value is going to be 1 into 2 into 2 into 3. This is equal to 12. Okay. So the trivial solution, the very first solution of the equation of the identity a square plus b square plus c square equal to d square, we get by observation, that is 12. But we have to ensure that whether this is the correct solution or not. We are not testing with other values. We don't know whether other value is possible or not. We have to get some idea from here that integers are of the form, when a number divided by 2, we take integers of the form 2k plus 1. Okay. Integers can be of the form 3k plus 1, 3k plus 2. Here, when you consider these integers, see, there are two conjugative integers. Their product is always divisible by 2. This is also again conjugative integers. Their product is divisible by 2. So when you multiply, product is always divisible by 2 into 2. This is equal to 4. Because there are two conjugative integers, there are also two conjugative integers. So product is always divisible by 4. So one factor of ABCD, if we use little bit sense of integer, one factor of ABCD is always 4. But here ABC is the least value, we got 12. This is justified if we prove that this product is divisible by 3 also. Let us see whether it will be divisible by 3 also. So for that, we'll check the divisibility by this thing. In integer, there is a concept that if an integer divided by 3, the remainder will be 0, 1 or 2. So that's why when you test divisibility with 3, we can start taking integers in this form: 3k plus 1, 3k plus 2. For n equal to 3k, see what is the value of a, b, c, d. A, b, c, d we are getting n plus 1, n into n plus 1, n into n plus 1 plus 1. So for n equal to 3k, if you put, it is obvious that for n equal to 3k, we just substitute the value 3k over there. For 3k taken here, this product is divisible by 3. This product ABCD is divisible by 3. Now we have to test with n equal to 3k plus 1. For n equal to 3k plus 1, will this product be divisible by 3? That a into b into c into d, you just substitute there. This is 3k plus 1. For n equal to 3k plus 1, it will be 3k plus 1 plus 1. This thing will be what? 3k plus 1 into 3k plus 2. And this thing will be what? 3k plus 1, if you just put the value over there, the first one is 3k plus 1, then 3k plus 2 plus 1. This is not divisible by 3, not divisible by 3. Their product also not divisible by 3, but this is divisible by 3. Why this is divisible by 3? Because if you expand it, this will give you what? This will give you 9k square plus 9k plus 2 plus 1, 3. Since this sum is divisible by 3, plus 3 also divisible by 3. So now for n equal to 3k plus 1 also ABCD, this product P equal to ABCD, product is P here, P equal to ABCD, product P equal to ABCD, it was divisible by 3, this time also it is divisible by 3. So for all values of n, it is divisible by 3 or not, we have to check with the other value of n, because divisible by 3 means that integers can be taken this form also for n equal to 3k plus 2. What will happen for n equal to 3k plus 2? If you find the product P equal to A into B into C into D here, it is 3k plus 2, then 3k plus 3, then 3k plus 1, already done. Fourth one, if you need not write, this n into n plus 1, keep it unchanged. Here only you are getting divisible by 3. So if one of the factor in the product divisible by 3, the whole product is divisible by 3. So ABCD now has a factor. If you draw the conclusion, we have drawn the conclusion here, it is divisible by 4. Now by putting n equal to 3k plus 1 and 3k plus 2 and studying case by case, we observe that n is divisible by 4. No, n is divisible by 4. Okay. So when n divisible by 3 we have seen, now we are seeing n divisible by 4. Therefore n equal to that product ABCD always divisible by 3 into 4. This is 12. Divisible by 12. And 12 is the least integer which is divided by itself. So the value of m also going to be equal to 12. Little bit concept of integers we have used here. Let's see the next problem. This problem number 3 in RMO 2023 also we need the concept of integer, but number theory never. Number theory don't need. Just integer concept will be enough. What is given there? For any natural number n expressed in base 10, Sn denote the sum of all the digits. Okay. Find all natural number mn such that m is less than n. You must observe this part. And Sn square m, Sn square n. Okay. M will be less than n. Sn square equal to m and Sn square equal to n. So question initially when you observe, you think that it's a huge number theory problem. You need so many concepts here. We have to find Sn square m and Sn square n. But I am telling you, it is true that some can be approached by an extraordinary student of class 8 also. Base 10 concept all of you know. Numbers normally we use in the sense of base 10. Now for those numbers, you have to find natural number mn. This ordered pair you have to find for which m is less than n. Some of the digits in the first case, that its square is m. Some of the digits in the second case, its square is the previous one. So question, number can be of any digit form. Can it be 5-digit form? Can it be 6-digit, 9-digit? Then I'll spend my whole life to find those numbers. I'm telling you no. You just See the statement here, find all natural numbers m such that Sn squared, sum of the digits. Suppose you have taken a number which is say 6 digit. 6 digit number, the maximum value of a 6 digit number, if you consider, it is 6 nines. What is the value of S5? If it is a 5 digit number, S5 is what? 6 into 9, that is 54. But 54 square is what? Suppose you have taken this one as m or n, whatever. N you have taken this one. Now you have taken S5 equal to 54. What is the value of 54 square? 54 square, if you just substitute 2916. If you have taken n equal to this thing, then S5 is 54 and m is going to be equal to 2916. But see the condition. Sm square, now it is what? It was n. We found Sm, that is 54, by taking maximum. Now if it is m, what is the sum of the digits? You just check sum of the digits here. 2 plus 9 plus 1 plus 6. This is 11, 12, 18. 18 square is 324. So if you have started with n equal to this, m is this, and then n you are getting this. Is it possible? No. This is not possible because sum of the digit for the second number m also, its square will be equal to n. So obviously it is not matching. It cannot be a 6-digit number. Similar case will arise for a 7-digit number. If you have taken n equal to 6, 7 nines, then 63, its square. If you calculate, then n and m will not match. So if you take digits more than 6 number of digits, then it is not matching. Now if it is of 5-digit number, n equal to say 9999 is the maximum value. So S, it was a 6, not 5. So S5 will be what? This is 45. 45 square is 2025. If you have started with this, 45 square 2025. Now 2 plus 2 plus 5 is 9. Its square is 81. N cannot be 81. N cannot be less than m. Okay? If you have taken Sm square 2025, it's coming 81. So not matching. It will happen for any 5-digit number. So it is not possible. What will happen if you take 4-digit number? Let us check with the maximum value. N equal to 9999. So sum of the digits S4 is going to be equal to what? 36. 36 square is 1296. Now 1 plus 2 plus 9 plus 6 is what? This is 15. 18 square. 18 square is 3. So obviously it is not matching in this case also. It cannot be a 4-digit number, and we cannot check with all these numbers one by one. Okay. So I will be taking the help of a table. So I have done it in the form of table here. For n equal to 1, Sn is 1, Sn square is 1, Sm 1, Sm square also 1. Not possible. Because m should be less than n. Here for it is 4. It is 4, 16. We are taking perfect square because the problem we have started by taking mn as integers and their perfect squares also. So 1-digit perfect square numbers taken into consideration. Isn't it? N and m both are perfect square in the problem. That's why 149, and we do all the necessary calculation here. But n started with 9, we are getting 81. So n equal to 1 is not possible. N cannot be 1-digit number. This is not equal to 1-digit number. Can it be of 2-digit number? If you go on calculating, this part is going to be 7. If you find all these things, then this part 7, and if we put the value here, that Sn square, it will be 49. This part is 13, 169. Not possible, because this is started with 16, now it is 169. It is not possible. If we have started with 25, the sum is 7 only, same situation. Okay, there is no difference. If we start with 36, it is 9, sum of the digits, and here its square is 81. Then this sum is again 9 and 81. See, with 36 we are getting 81. With 49, the sum is 13, 169. 16 square is 256. No, it is not 16 square. It will be sum of these. That is 16. And it is 256. Not possible. 64. Sum of the digits 10. It is 100. This thing is 1. 1. And its square also 1. Not possible. This is 9. 81. Similar situation, 981. You would have taken this one. You are getting n back here. Same n you have started with. This is your n. See, table column n. This is also n. But you can't take because it is given m is less than n. Okay. M is here 81. N is 81. Not possible. That's why. Now let us try with where we get the solution. It was not 5 digit, 4 digit, even more digits not possible. Now we have seen that it is not possible for 1 digit number, not possible for 2 digit number. Is it valid for 3 digit number? Let us calculate Sn. It is 1, 1, 1, 1. No. So this one is 1 to 1. That is 4, 16. So this part is 749. No. If it is 5, if you have taken, no, not 5, sorry. If it is 441, that is 144. 144 is 9, that is 981, 981. No. If it is 2 to 5, then 5 to 7, 9. Again the same situation. We did not calculate. 256. It is Sn equal to 13. Now for 256, this is 13. Sum of the digits. Square is 169. Sum of the digits here is 7, 9, 16. And its square is 256. If it is 289, it is 19. Then its square is, oh my god, this is not 169, this will be 196. And this is what? 361. This is 10, 100. Not possible. Here it is 9, so this row will be repeated. So this is the only solution. What is the value then? What are the values of m and n for this problem? This you can see from here that n is 256 you have taken, you got m equal to 196. So the solution is m equal to 196 and n equal to 256. Both the conditions are obeyed. M less than n and Sn square is n, Sn square is n. This is the only solution here. M 196 and n 256. Okay.